video, we're going to take a look at a couple of examples of how to use Euler's method. If you haven't had a chance yet, please watch my previous video, which goes over the basic concept of Euler's method, why we use it, and how it's basically set up. If you also haven't taken a look yet, I've also shared this handout with you that is a brief overview of what we talked about in the first video, giving you a visual idea of what Euler's method is all about. So for the first question, we're going to take a look at the AP exam from 2010 and question 5. And I'm only going to focus our attention on this video on just part A. So in the problem, they say consider the differential equation up above. We're using dy dx as 1 minus y. And so in part A, they want us to use Euler's method starting at x equals 1 with 2 steps of equal size to approximate f of 0. And we want to show the work that leads to the answer. So they've already acknowledged to us that the initial condition here of 1 is going to be 0. And so when x equals 1, the y value is 0. So we already have our x comma y value of where we're starting at. So we're going to start at 1 comma 0. Now we want to approximate f of 0. So we're going to want to use 2 steps of equal size. And so that's referring to my delta x. So my delta x here needs to be 2 steps that are in between 1 and 0, which means my delta x is going to actually be 0.5. Now, because I'm going from x equals 1 to x equals 0, I'm actually going to make it negative 0.5 in this case. So here's how I would like to set this up. What we want to do is essentially create a little slope, a little dy dx of what that slope is at 1, 0. We're then going to use an change in x of negative 0.5. And to figure out delta y, we mentioned this in the other video, it's essentially just going to take your dy dx value and you're going to multiply it by your delta x. So in this question, we have a pretty simple differential equation. It's just 1 minus y. And so when I use the y value of 0, I'm going to have 1 minus 0, which just gives me a 1. So my dy dx is 1, and my delta x is negative 0.5. And so that gives me a delta y of negative 0.5 as well. And so that's going to allow me now to find my next ordered pair, which is going to approximate 1 plus negative 0.5 is going to give me 0.5. 0 plus negative 0.5 is negative 0.5. So I actually have the approximation now for x equals 1/2. I want to go one more step of this. So I'm once again going to take this and I'm going to plug it into my dy dx above up here. It's going to be 1 minus, and in this case, a negative 0.5, which is really the same as me asking me 1 plus 0.5. So that means my dy dx in this case is going to just be 1.5. Since my delta x is still negative 0.5, I'm now going to take my 1.5 and I'm going to multiply it by negative 0.5. And so that's going to give me negative 3/4 or negative 0.75 if I leave this in decimal form. And so to get my final step here, I'm going to take the 0.5, add my delta x to it. 0.5, that gives me my x equals 0, which is what we were going for here. And negative 0.5 plus negative 0.75, that's going to give me a grand total of negative 1.25. You can also write that in fractional form. And so the answer here for part A is just going to be f of 0 is going to be, and we should change that from equal to approximate. Let me find my eraser. So we're going to change that to approximate negative 1.25. And that's going to be my answer for the part A of this question. Let's look at one more example, and this one is going to be from the 2013 exam. So same idea, we're going to have a differential equation that's been given to us, and we're going to actually skip down to part B for this question. So once again, we want to use Euler's method. We're going to start at x equals 0 using 2 steps of equal size. That's our delta x it's asking us. So that's what it's asking us there. And we want to approximate f of 1/2. So since I'm going from 0 to 1/2 and I want to do 2 steps of equal size, that's going to tell me that my delta x here has to be 1/4. That's going to be 1/4. So in order to set this up again, I like to use a chart just to kind of make things a little bit easier. I have my original x and y. Then we compute its dy dx value. Then we'll have our standard delta x, which is always going to be essentially given to you. Again, here we have to do a little bit of math to figure it out, but nonetheless, it's the same type of idea. And then our delta y, and again, don't forget that that's just dy dx times delta x. So let's go ahead and evaluate this. So my xy here, they've given up in the initial condition as 0, comma, -1. My dy dx, well, I'm going to find that by taking this and I'm going to plug it up into the original function. So I'll do the work over here for that. -1 squared, 2 times 0 plus 2. So that's going to be 2 times 1, or just 2. So it's going to be 2. My delta x, again, is a standard 1/4. That's already been given to me. 2 times a fourth is 2/4, better known as a half. I'm going to take these two numbers and I'm going to add them into my x and y respectively. So I'm going to have a new x value of 1/4, and I'm going to have a y value of -1/2. Once again, we're going to take this x and y value, we're going to plug it into my dy dx up above. So that's going to give me, and we'll write this out, it's going to be -1/2 squared, 2 times a fourth plus 2. So this one we just got to be careful with. This is going to be a positive answer. It's going to be 1/4. This is going to be a half plus 2. So that's going to be 2.5, which is also 5 halves. So which means my answer here is going to be 5/8. 5/8. My delta x, once again, is still going to be 1/4. And now I'm going to multiply these together. So this is going to give me 5/32, it looks like. And so last but not least, we're going to add these together. So this gets a little bit flustering. We have -1/2 plus 5/32, which is, well, again, -1/2 is the same thing as -16/32. So that's going to actually give me an answer of -11/32 as my final answer. So this is going to be what I have, and so therefore I'll finish answering this question. It's going to be f of 1/2 equals -11/32. That's my approximate value using Euler's method.